Video, we will learn how to draw molecules using Lewis structures. But before we move to Lewis structures, we will start with what are known as electron dot diagrams. Now, these are means of representing atoms when doing rough work towards modeling molecules. Now, each diagram consists of the symbol for the element and a dot for each valence electron. So for instance, fluorine has 7 valence electrons, so we are going to draw 7 dots around fluorine, like so. Carbon has 4 valence electrons, so we are going to draw 4 dots around carbon, just like that. Now, moving on, we will now learn about how to draw what are known as Lewis structure. So these are essentially models drawn on paper that represent molecules or polyatomic ions. Now remember, molecules are groups of atoms that are covalently bonded together. Polyatomic ions are similar, but they're just charged. The purpose of Lewis structures is to show the locations of the valence electrons with respect to bonds and the atoms. Each covalent bond consists of 2 shared electrons and is drawn as a line. Unshared electrons are put in pairs and are drawn as a pair of dots known as lone pairs. So remember, line indicates a bond. Now these are shared electrons. Pair of dots indicates lone pairs. These are unshared electrons. All right. Now there are a few rules to drawing Lewis structures, and I've indicated them here. So number 1, sum all the valence electrons from all the atoms in the formula. Number 2, choose the central atom, usually the least electronegative. Now this is also typically the atom that is written first in the formula. Number 3, use a pair of electrons to form a bond between each pair of atoms. And number 4, finally, rearrange the non-bonding electrons so that each atom has 8 electrons. So as an example, I'd like to use carbon tetrafluoride to show you how to draw Lewis structures. Now, to go back to our example of electron dot diagrams, remember carbon has 4 electrons, 4 valence electrons, that is, and each fluorine will have 7 valence electrons. Now, there are, as I said, there are 7 valence electrons for fluorine, 4 for carbon. Now, if we combine these numbers, so it'll be 7 times 4 plus 4, 28 plus 4, we have to take care of 32 valence electrons. Now, carbon is written in front of fluorine, so we will consider carbon as our central atom. Now, moving on to number 3, we'll use pairs of electrons to form a bond between each pair of atoms. So conveniently, fluorine has 1 electron remaining, and this can bind to 1 electron from carbon. And you can imagine that we can do this for all 4 fluorines, like this. I'll just get rid of this for now. And voila, this is the Lewis structure for carbon tetrachloride. Now, for most atoms, the happy number that I like to call it is 8. So most atoms are stable when they have 8 electrons. Now this is called the Octet Rule. The only other atom that has the only other main atom that goes by a different number of valence electrons is hydrogen, which allows for 2 electrons, and this is called the Duet Rule. Okay. In some cases, such as carbon dioxide, and you can try this out on your own, we would draw Lewis structures like these. So this is the Lewis structure for carbon dioxide. If you check, each oxygen and carbon has 8 electrons surrounding it. It is in this, as you can see in carbon dioxide, it's possible to have 1, 2, and in some cases we may even have 3 bonds between a pair of atoms. These situations are called single, double, and triple bonds. So for instance, an example of a triple bond can be found with hydrogen cyanide, which we draw like this. With multiple bonds, the number of electrons shared between the two atoms is 4 or 6, depending on the type of bond, instead of the usual 2 electrons within a single bond. Now, the more bonds there are between two particular atoms, the stronger and shorter the bond is. For instance, a carbon-carbon triple bond is stronger than shorter than a carbon-carbon single bond. Now, they're shorter because you can imagine that the force of attraction, now remember, bonds are forces of attraction. This force of attraction is shorter. That's why more multiple bonds lead to shorter bonds.